gentlemen and ladies, good day. We continue with renal anatomy and physiology, and we now begin to focus on the structural or functional units of the kidney. That the smallest functional unit of the kidney is the nephron, and we have over 1 million nephrons in our bodies. So these are responsible for the various functions that the kidneys perform, including formation of urine and the related functions of hormone production and all those things. The nephron consists of components of blood vessels and components of what is called non-vascular or tubular system. So the blood vessel components form knots of capillaries called glomerulus, which is a convolution of capillaries that is called the glomerulus. This is covered by the Bowman's capsule, from which the tubule system develops. And the tubule system is a composition of the various parts that are named according to the distance that they are from the Bowman's capsule. So the components of the tubule system that are closer to the Bowman's capsule are called the proximal components of the tubule system or the nephron, and those that are further off from the kidney Bowman's capsule are called the distal components. Now, because of the nature of convolutions of the proximal as well as the distal components, these are also called convoluted tubules. So we have the proximal convoluted tubule and the distal convoluted tubules. In between, we have a portion of the nephron that was described by Henle. So they are called Henle's loop because it makes a loop that is shaped like hairpins, and so it is called nephron's loop, which has a component that drains the fluid downwards and a component that drains the fluid upwards. So it has the descending and the ascending components. All these filtrate ends up into the collecting ducts. They are called collecting ducts because they are connected to at least 2 or more nephrons. So in terms of the glomerulus, so the glomerulus is that specialized capillary bed drained by arterioles. So the arterioles we have the larger one and the smaller one. The one that drains blood into the glomerulus is called the afferent arteriole, and the one that drains blood out of the glomerulus is called the efferent arteriole. The afferent arteriole is wider than the efferent arteriole. This ensures that there is high pressure of blood that goes into the glomerulus, and there is less drainage of this blood out of the glomerulus. This ensures sufficient filtration of the blood to ensure that at least 1.5 mL of blood is filtered per minute. Then we continue with the glomerulus, that the glomerular capillaries are covered with special cells called podocyte cells. These podocyte cells cover these capillaries and add to as an additional barrier, biological barrier of the filtrate for it to be filtered. So the blood has to pass through the capillaries as well as the podocytes. Now the spaces in between the podocytes is what are called podocyte slits, through which this filtration takes place. So the renal tubule, as I said, the renal tubule is divided into components, and this is the portion of the nephron that modifies the filtrate. So there will be reabsorption of some materials and the secretion of back of some of these materials into the filtrate. So if you notice, that will be the glomerulus developing from blood vessels, and then we have the tubule system developing from the Bowman's capsule. So the first part is the proximal tubule, and then we have the descending and the ascending portions of the loop of Henle that ends into the distal convoluted tubule, and then the collecting ducts. So then also what you notice is that we have a situation where the um, the tubule system develops and passes between the afferent and efferent arteria. This is important for auto um, um, the auto control, automatic control of or self-regulation or self-control of the nephron by creation of the presence of what is called the juxtaglomerular apparatus. So blood supply of the nephron, the efferent arteriole divides into peritubular capillaries that cling very close to the renal tubule. This helps to supply oxygenated blood and nutrients to the tubular cells, as well as to provide an environment for reabsorption of materials back into blood or secretion of unwanted substances that could not be filtered back into the filtrate. So the juxtaglomerular apparatus is made up of cells of the thick ascending portion of the loop of Henle, which are the macular dense cells. Also, part of the cells in between the afferent and efferent arterioles called granular cells that secrete the renin, and then we have mesangial cells which are contractile and they are able to pull the afferent and efferent arterioles together. So that is the juxtaglomerular apparatus. And then finally, the types of nephrons. So remember we said we have more cortical, we have more nephrons in the cortex than in the juxtamedullary portion of the nephron, the kidney. So the nephrons that are found in the cortical areas, they are called cortical nephrons, and they are located entirely in the cortex. They include most of the nephrons. Then the medullary nephrons are fewer and are found in between the boundary of the cortex and the medulla, but they have their loop of Henle dipping deep into the medulla as illustrated in the figure below. Thank you. We will be discussing next how urine is formed.